Motion in one dimension. We all know what the distance between two objects is, but do we really know what it is? Let's think about it for a second. What is distance? What is length? Think about what you would define that as, but you're not allowed to use the word distance or length in your definition. Hopefully you've just had some discussion on the definition of distance. And unless something really incredible has happened, you've been unable to define distance without using the word interval or distance or length. That's because distance is a fundamental part of nature. It is so fundamental that it's really impossible to define. We all know what it is, but we really can't say what it is. But we can compare distances. For example, here's a little sign marker that says Boston is that way. Seoul is this way, about 34 miles. Coney Island's like 7,000 miles this way. So what we're doing is we're coming up with a location, Boston, Seoul, Coney Island, etc., saying which direction it is. We're pointing, okay, because again, it's very hard to define what direction is. And we're giving a number value that is comparing the locations of these two objects. And see, it's even hard to say this, but we are comparing distances. So we can compare the distance between two objects to the distance between two other objects. On the previous slide, we could see how far that marker was from Seoul, and we also saw how far it was from Coney Island and several other points of interest. So for convenience, and so we can talk to each other and compare distances, we will create standard distances. This way, everybody who talks about it, we can make sense of it and come to an agreement how far things are apart. For physics, we will be using meter as our unit for measuring distance. It's been accepted as a universal standard throughout the world, so everybody knows what it is. Again, we haven't defined what distance is, but it will allow us to work with it. We'll be using the meter as our standard for measuring distance. This drawing here, is half of a meter stick. You probably have several of these in your classroom. And you can see it has numbers 10, 20, 30, 40, 50. Those are centimeters, and there are 100 centimeters in 1 meter. So this mark here, where you have 20 centimeters, this is 0.2 meters from here to here. So we're going to use a symbol for distance as little d, and the unit for meter is little m. Let's introduce another fundamental term to help us understand motion in one dimension. This will be time. Everybody knows what time is, but try defining it again. Take a few minutes, see if you can come up with something. However, you can't use the word time or any equivalent word to time, like hours, seconds, how long it takes, anything like that. Just try it for a few minutes. Like distance, time is a fundamental aspect of nature. It's so fundamental that it's impossible to define, unless somebody in the class came up with something. We all know what it is, but we really can't say what it is. However, like distances, times can be compared, and this is the key point. We can compare different times. Here's how we'll work with time. We're going to say that a person running around this track here at a high school, we're going to say that when the person made 1 lap around the track, the second hand on your watch went around once. So the run took 60 seconds. We're comparing the time between two events. One event is the person running around the track, and the other event is the second hand on the watch going around one complete time. We call that measuring time. We still haven't defined time, but now we're able to work with it. In order to compare time with everybody on the planet, so we're all working with the same units, the second has been defined as the standard for measuring time. The symbol for time is a lowercase t, the unit for a second is lowercase s, and here's a second hand on a watch, and if it keeps going this way in a clockwise direction, by the time it gets to the top, This interval, this time interval, is 10 seconds. You can click here for a nice video on how to measure time and distance. We're going to define a quantity now that is not a fundamental aspect of nature, but is the ratio of two things that are. Speed. We're going to define speed as the distance traveled. Remember, we really can't say what distance is, but we can compare it to other distances, divided by the time. Same on that, we can't really define time, but we can compare it. So, the distance divided by time, we're going to define as speed. We'll use S here for speed, D for distance, T for time, and don't confuse this S with the S we have for seconds. Okay, when you see it in this format, that's speed. Again, speed is not a fundamental aspect of nature, but it is a ratio of two things, distance and time, that are. We need units for speed, and the way we're going to do that is take the equation for speed. Here it is, speed is distance over time. We will put in the units for distance, which are meters, units for time, which are seconds, and we're going to say that the unit for speed is meters per second. And we can leave out the ETERS and the rest here on seconds and just put M over S. That's read as meters per second, and that's the unit for speed.